Have you ever wondered how search engines and databases are able to quickly find information among millions or even billions of the data entries? The answer lies in a binary search algorithm, which is the fundamental concept in computer science. Good morning, ladies and gentlemen. My name is Mr. Azarcon, and here with me, Miss Abejero, Mr. Apante, Mr. Hiquiana, Miss Jimenez, and Mr. Morales to welcome you all to our presentation for the research entitled Optimizing Binary Search Algorithm, Improving Time Complexity and Search Accuracy. Today, we will explore how we can further improve the efficiency and accuracy of this algorithm. So let's dive in and explore this important topic together, such as the background of study, statement of the problem, objectives, significance of studies, scope and delimitation, methods of research, theoretical background, and source of data. First and foremost, please allow me to give you a brief summary of our research study. Well, this research algorithm, this binary search algorithm is widely used but needs improvement in time complexity and search accuracy. Well, some type of data, such as dynamic or unstructured data, may not be suitable for binary search and may require more sophisticated search algorithm. While binary search is a useful algorithm, it may need improvement in terms of time, complexity, and search accuracy, particularly in a scenario where the input data is not sorted, unique, and very large. In addition, these research aim to optimize the algorithm by conducting experiment and reviewing literature. We conduct multiple trials to compare several iterations of the binary search method in order to achieve our objectives. Additionally, we review previous research to identify potential area for improvements. Well, the technique could be greatly simplified in terms of time, and we have suggested some changes that could increase search precision. Lastly, the result will contribute to algorithm optimization and have particular implementation for various applications. We believe that our research findings will be useful in enchanting the binary search algorithm. With potential application in a various field, we anticipate that our result will advance the algorithm and inspire further research in this area. So as we continue, the background of study, let me discuss to you our background of study. Well, what is the binary search and its efficiency? Well, binary search is an algorithm for searching for an element in a sorted array by dividing the search interval in half and checking whether the target value is greater than, less than, or equal to the middle elements of the interval. It has an efficient of O log n in the average and base case scenario, where n is the number of elements in the array. In addition, what are the goal for optimization or optimizing the binary search? Well, the goal for optimizing binary search are to improve its complexity and search accuracy. This can be achieved by reducing the number of steps required to find a target value and using more sophisticated search strategy that considered the destruction of this contribution of value in the list. Furthermore, what are the techniques for optimizing binary search? Well, the technique for optimizing binary search include using different data structures such as balance tree, hash table, and B trees. Implementing the algorithm in parallel and using specialized hardware. Additionally, more sophisticated search strategy like widgets, binary search, and interpolation search can be used. Lastly, what is the importance of optimizing binary search? Optimizing binary search is important due to the increasing size of database and need for fast and efficient search algorithm. It has numerous real-world applications such as improving search engine performance and enabling faster data analysis in scientific computing. Advancement in the optimization of binary search can contribute to making search algorithm faster and more accurate, which can benefit a range of applications like search engines and database. As we proceed, Ms. Jimenez will discuss the statement of the problem.
Moving on, we prepared possible questions about the content of the statement of the problem. For the statement of the problem, how can optimizing the binary search algorithm help users in searching data more efficiently and accurately? In order to do that, the goal of this research is to optimize the binary search algorithm to improve both its time complexity and search accuracy. The current binary search algorithm has a time complexity of O log n, which can impact its overall efficiency, especially for large data sets. Can interpolation search algorithm variant be used to improve binary search algorithms? And if so, how does it work? Improving the time complexity of the algorithm can be achieved by reducing the number of steps required to find the target value, while improving search accuracy can be achieved by using more sophisticated search strategies such as interpolation search. Interpolation search algorithm can be used as a variant to improve the binary search algorithm in cases where the data being searched has a non-uniform distribution, allowing for faster search results and more efficient data analysis. By optimizing the binary search algorithm, users can benefit from faster search results and a more seamless user experience, as well as more accurate and reliable search outcomes, minimizing the number of false positives and false negatives. How can combining the interpolation search and binary search algorithms lead to a significant improvement in search performance? The combination of interpolation and binary search algorithms can lead to a significant improvement in search performance compared to using either algorithm alone, providing faster, more accurate, and more user-friendly search results. Moving forward, let me introduce to you Mr. Apante for the objectives of the research.
Now, let's dive into the objectives of optimizing binary search. As we all know, binary search is a powerful algorithm used to search for a target value in a sorted area of elements. However, there are ways to optimize binary search further to improve its time complexity and search accuracy. The first objective is implementing binary search iteratively. We are designing a usage of iterative function to repeat only some part of the code rather than using a recursive function that calls itself again to repeat the code and can lead to a significant amount of overhead in function calls. Second is reducing the number of comparisons in a typical binary search. The target value is compared with the middle element of the array. However, instead of comparing the target value with the middle element, we can compare it with the first and last elements of the array. By using this formula, we can reduce the number of comparisons in the binary search algorithm. This formula is used to estimate the position of a target element in an array based on the values of the first and last elements and the target element itself. It calculates the estimated position by determining the distance between the target element and the first element and multiplying it by the range of indices between the first and last elements, then dividing it by the difference between the values of the last and first elements. Once the estimated position is calculated, the algorithm compares the value of target element with the value of the estimated position and narrows the search accordingly until it finds a target element or determines that it is not in the array. Third is using a hybrid approach. In a hybrid approach, we can first perform a linear search on the array to find an element that is close to the target value. Once we find such an element, we can use binary search to narrow down the search space and find the target value. This approach can be more efficient for datasets with a small number of elements. The fourth and the final objective is handling duplicates. In a sorted area with duplicates, there can be multiple occurrence of the target value. By default, binary search returns the index of the first occurrence of the target value. However, we can modify the binary search algorithm to return the index of the last occurrence of the target value. As we continue, here's Ms. Abejero will discuss significance of the study and the scope of the limitations.
Going forward, the significance of optimizing the binary search algorithm lies in its potential to improve search accuracy and efficiency in various areas of computer science and information technology. Participation in the study allows respondents to have a direct impact on the optimization of algorithms, while students can gain hands-on experience and knowledge in optimizing algorithms. The community can benefit from the enhanced accuracy and performance of optimized algorithms, leading to improved software and tools, faster data processing, and better results in various fields. The research can also serve as a stepping stone for future researchers in areas such as AI, machine learning, and big data processing. And for the scope and delimitation, the study focuses on optimizing the binary search to improve its time complexity and search accuracy. It explores alternative algorithms such as ternary search and jump search. The delimitation of the study includes a focus on time complexity and search accuracy, only considering the standard binary search algorithm and not covering advanced topics such as parallel binary search algorithm. The researchers plan to use interpolation search to improve the time complexity and search accuracy, but note that it is only suitable for uniformly distributed data. Going forward, here's Mr. Morales to discuss the theoretical background of the study.
I will be presenting to you the theoretical background of the binary search algorithm, a fundamental algorithm used in computer science to search for a particular item in a sorted list of elements. First, let's talk about how algorithm works. The binary search algorithm works by repeatedly dividing the search interval in half until the element is found. This is accomplished by using two pointers, a left pointer and a right pointer, to define the search interval. The middle element is calculated using the formula left plus right divided by 2. And the search interval is divided into two halves based on whether the target element is greater or less than the middle element. This process is repeatedly until the target element is found or the interval is empty. Now, let's move on to time complexity of the algorithm. The time complexity of binary search algorithm is O log n for a list of n elements. This is significantly faster than linear search with a time complexity of On. In other hand, in other words, as the number of elements in the list increases, the binary search algorithm becomes increasingly more efficiently than linear search. To optimize the binary search algorithm, researchers can focus on improving the time complexity and search accuracy. One way to enhance the time complexity is by implementing the algorithm iteratively rather than recursively, which eliminates the overhead of recursive functions calls and reduces the algorithm space complexity. Another way to improve the time complexity is by using bitwise operators instead of arithmetic operators, which can perform operations faster. The accuracy of binary search algorithm can be improved by implementing variations of algorithm such as interpolation search and exponential search. Interpolation search uses a mathematical formula to estimate the position of the target element based on its value and the values of the first and the last elements in the list, which can reduce the number of iterations required to find the target element, especially for lists with evenly distributed elements. On the other hand, exponential search is a variation that uses a binary search approach but starts with exponentially increase in interval size instead of the full list. This can further reduce the time complexity of the algorithm, especially for large lists. As we press on, here is Mr. Hiquiana who will present the proposed solution and outsource of data.
I will iterate to you our proposed solution to the problem. Our first proposed solution is using an interpolation formula to calculate mean. This interpolation formula calculates the position of a value within a sorted array by using the values of the array lower index and upper index. It does so by scaling the difference between the value of the array and the value of the lower index by the ratio of the difference between the array values at the lower and upper index and adding that to the lower index. This allows for a more accurate estimation of the position of the value within the array, especially when the array is large and the value is closer to the upper index. Second is to use binary search as fallback. In the event that the interpolation formula fails to produce a valid index, such as the calculated index is outside of boundaries, the binary search can be used to locate the desired element. This can assist us in handling special situations where the interpolation formula fails. Third is to handle duplicates. In cases where the array has duplicate elements, the interpolation formula may not always work as expected. To address this, we can add validation to the interpolation formula to remove the duplicates into account and modify the search in accordance with that. Fourth is to handle non-uniformly distributed data. Binary search algorithm assumes that the data is uniformly distributed within a sorted array, which allows for an efficient search for a particular value. However, if the data is non-uniformly distributed, binary search may not be as effective. To handle non-uniformly distributed data in binary search algorithm, we can modify the algorithm to use interpolation search. Interpolation search also assumes a sorted array, but instead of always dividing the search interval in half, it uses interpolation to estimate the position of value being researched for. And lastly, to use a good hash function, we can use a hash function to map the value of the array into a hash table. A good hash function can significantly reduce time complexity of binary search algorithm by reducing the search space and providing faster access to the values. One example of a hash function that can be used to optimize binary search is the modulo function. The modulo function maps a value to a hash table index by taking the remainder of the value divided by the size of the hash table. This function is efficient and can be used for integer data types. And for our source of data, we created our own two sets of data array so that we can test our modification in the binary search algorithm. In our first method, we created a long array to accommodate large data of integer. We also written a for loop to add value to the array that depends on the parameter that the user wants to input. In our second method, we created a string array to accommodate large data of string. We have also written a for loop to add a value to the string array that depends on the parameter that user wants to input. In that way, we can have a large data of array to test our optimization in binary search algorithm. And for our closing remarks, here's Ms. Jimenez.
Thank you all for your time and attention today. It has been a pleasure sharing our research on optimizing the binary search algorithm. We appreciate your support and look forward to continuing to contribute to the advancement of this field. Thank you and God bless.